exam, let me tell. This exam, for section 9 students, I finished the correction. That means I went to the system and I just, if there is any discrepancy in the grades, that means if there is a negative sign, positive sign, kilojoule, joule, all those things I give marks. Okay, so for those deserving students, your marks are added. I did only for one section, section 9. It's taking too much time. So section 7 and 8, maybe this week or next week I will do. Okay. So don't worry about it, but this you will get, this benefit you will get only for this exam. Next exam onwards, if and even for the scientific notation, no scientific notation, those who got wrong, that also I gave marks. Okay, I will give marks for section 7 and 8 also, and that is applicable only for this exam. Next exam onwards, you need to be very careful. So it's your responsibility. You agreed, right? Did you hear what I'm telling?
Yes,
Only,
doctor.
only Syed heard, others didn't hear.
We heard, doctor.
You heard, okay? So now next semester, next exam and next courses, if you send me the grades and this thing, there is no use. So this I will help only for this exam, okay? Because next, this is the first time maybe you had confusion and all that. And plus the exam was so easy. All the questions we solved in the class and everything we solved in the class. And then how come, I don't know, some people made mistake, but majority of the students did extremely well, very well. Last semester people, they got low marks. This semester you all got very good marks. Okay, even after the correction, so many people got full mark also. Okay, and say your case, I sent it to the publisher. Okay, yes. I took the screenshot and I sent it to the publisher, and he will give me a reply today. Okay, so you don't have to worry about it. Okay.
Thank you.
I know you personally because your voice, your face, I don't know, but your voice I know very well. Yeah. Okay. Yeah, so let's start. Before we start, I just want to show you some questions where you made, majority of the students made mistakes. Okay. See, I'll tell you how to solve it. Most of you did correctly, but then some people made a few questions wrong. You should not. That there was a question, magnesium question. That question I solved in the class. Do you remember before the first quiz? Okay, yes. Even that you made wrong. So that is so bad. That was one of the questions you made wrong. Okay, let me see which PowerPoint is that. Okay, this one. Yeah, okay, this was one of the questions you got wrong. I'll tell you how to solve it. Okay, oh. Okay, I'll tell you the method. This is the correct answer. Okay, can you see? You can just check it. A quantity of 1.922 gram of methanol was burned in a constant volume bomb calorimeter. Consequently, temperature rose. That means temperature increased. This is delta T. If the heat capacity of the bomb plus water is this much, calculate the molar heat of combustion of methanol. So this is for molar heat. Okay, yeah, same question we solved in the class. Okay, now tell me how to solve it. What is given here?
The Q of reaction is equal to negative Q of bomb calorimeter.
Yes, and the Q of the reaction is equal to minus Q of the bomb calorimeter. Okay, now come on. So that is equal to minus C delta T of bomb calorimeter. So here the bomb calorimeter and water, it's given together. So tell me the answer for this one. So it's minus of 9.02 kilogram. You be careful with the units. And delta T, the value of delta T is 5.26 degrees Celsius. Degrees Celsius get cancelled. So you get this much kilojoule. Okay, such a simple question. Now, this what's the next step? Tell me.
We find the ratio.
Yeah, just find the ratio. So this is for this much gram, this 1.922 gram, or you can just find a mole. If you want, you can find a mole. Okay, 1.922 gram, this much heat. What's the thing? 9.02 to 5.26 degrees Celsius. So you need to calculate for 1 mole. Molar heat means it's for 1 mole. Methanol CH3OH, its molar mass is, I think, 32. Okay, 32. So 32 gram per mole X. So you just find X. You need to calculate for 1 mole. Is it okay?
Yes, doctor.
Did you understand? You tell me how come it's difficult. I don't understand that. It is so simple. Now, this question also, you asked me a question, now, my dear. Who was that? Somebody during the class asked me a question during the exam. Look here, anyway. So here, which form you are supposed to find delta? Sorry?
It was me. I asked you about the specific heat.
Yeah. I was wondering how come you asked me the question.
Yeah, I was a little bit confused, but I figured it out and got it right.
Good. I thought you asked me again, but you didn't ask again. I thought then you figured it out. Okay. Yeah.
No, yeah, I got it.
Yes. Okay. Delta H is equal to that was for this question, dear.
Yeah, that was for this question.
Yes. So delta, and same question we solved also. Delta H is delta U plus delta N. So here in this case, delta N is equal to how this is graphite, it is solid. So it is here how many moles? It's 1. 1 minus half is equal to half. Everyone understood, no? Delta N we have. Now, the important thing is this is kilojoule. So the value of R is joule. So what you can do, you can convert kilojoule to joule. So what is it? Minus 110.5 10 to the power 3 is equal to delta U plus delta N is half 8.314. T is 298.15. So you will get delta U in joule. But I need to convert again to kilojoule because in the answer sheet you are supposed to write in kilojoule. So convert back to kilojoule. So how do you convert back to, suppose you will get the answer here, minus 111.7 10 to the power 3 joules you will get. Okay, so that's equal to minus 11.7 kilojoule. So this is the one. Okay, so you should not make the same mistake again. Or there is another way to do this. You can convert beginning itself the R value joule to kilojoule. That way also you can do. Okay. Yes. If you have something to ask, please tell me.
No, it was a mistake. Okay.
Okay. Yeah. Okay. Now. This question also we solved in the class. You remember this during a revision time I explained it. 0.3675 grams sample of solid magnesium is burned in bomb calorimeter. Specific heat capacity is given. Temperature, I think it's same as the other question, no? Methanol question. Okay, anyway, I will solve it. Can you please help me to solve it? Come on.
We will draw a relationship. We will find the Q and then relationship.
Q reaction is minus C delta T. So what's the value of C? What's the value of C here? Heat capacity? Minus 3024. Delta T value is how much? 3.009. This is for how many grams? This is for how many grams?
0.36.
Yes, so that means 0.3675 gram. The answer is minus 3024.3009 joule. And you need to calculate it per this much gram. So you are getting the answer in joule. You need to calculate for 1 gram. Per gram means, so 1 gram it's X. So you get the value of X in joule. So then how do you convert to joule to, so you will get joule per gram. So how do you convert joule per gram to kilojoule per gram? Divided by,
Molar mass.
so suppose you have X, So here X divided by 1000 kilojoule per gram. So this is the first one. Now B part of the question, kilojoule per mole. So that is here. This is for this much gram. Okay, so you can calculate it for 1 mole. So 0.3675 gram. It is minus 2. So this one into 3.009 joule. Now you need to calculate for 1 mole. 1 mole is how many grams of magnesium? 24.3050 gram per mole. This is the molar mass of magnesium. Here it is X. So you get the value of X, so and so. Okay. So and then how do you convert it into kilojoules? X over 1000 kilojoule per mole. This is the way. Everyone understood now? So you will get the same answer. Did you understand what I did?
Yes, doctor.
Okay, so please for the final in the hand, don't make the mistakes again. So that is why I solved the question. These are the questions majority of the students made wrong. So that's why I dictated those. Okay. Don't make please same mistake again. Okay, so now I will go for the portion. Okay. We did all the calculations. So many calculations I think we did, right? And now you told me you want some extra questions. That extra questions after finishing the lesson I will give you, okay?
We reached to question 7.
We did question number 7, right? This we finished. But some students, they told me they want more questions of this type. I will do it, okay? I will give you. I didn't get time to type questions because yesterday I was doing your sections again, no? So it was taking too much time. Okay. Anyway, I'll after finishing this lesson, I'll give you extra questions. Don't worry about it. Okay. So then now next topic in this lesson is models of reaction rate. Dear students, please don't sleep because this is theory portion. So I just need to explain. And from the theory portion, you lose marks easily. That is another problem. Okay. So be careful. You should not lose. You should not lose marks. Yeah. Okay. There are 2 different theories you need to do for explaining the rate of the reaction. One theory is given. Can you see the heading? Can you read the heading? It's called collision theory. One is collision theory, and another one is sorry, this is not the one. Another one is, can you see transition state model? This is the second one. I forgot to put the number. Okay, one is transition state model, and the other one is collision model or collision theory. See, now look here. I don't know how I will explain it because if it is in the classroom, I can show and explain. Anyway, during a reaction, reactant molecules collide. Did you get the point? Collision, they hit each other. That's the meaning. See, suppose this is this is a reaction. Consider this reaction, NO2 plus CO giving CO2 plus NO. So in this case, these molecules collide with these molecules. Collide means they hit. Okay. You understand what's the meaning of collision in Arabic?
Yes.
What's the meaning? Okay, now, but all collisions do not give product. Okay, so this is hitting with this one, but always you won't get the products. That means all collisions are not effective. Okay, for a collision to be effective or to lead product formation, to get product, 2 conditions must be followed. Condition number 1. Molecules should be properly oriented. That means molecules should be properly placed. Did you understand?
Yes.
Meaning of orientation. So usually I just show all those things in the classroom. Now I can't show. See, I will tell you the meaning. Look here. Look over here. So this is considered this reaction NO2 plus CO giving CO2 plus NO. Look here. This is CO. If it takes one O from NO2, you get CO2, right?
Yes.
Okay, and what is left after that?
NO.
NO. So you get NO. Okay, now how is this placed? Look here, in this case, this is N, here NO2, here C. So this C already it has O. This C is touching this one, hitting this one, it takes O and you get CO2. Understand? Understand?
Yes, doctor.
Yes,
Okay, so this is the proper orientation. Whereas if it is like this, N here, O here, O here, and C and O here, the CO needs one more O, but C is hitting N, right? You got the point?
Yeah,
This C, yes, this C is colliding with N because oxygen is on the other side. So this CO cannot take one O from here. So this is not a proper one. This is improper. Improper means not proper, not good. This is good one. Or I'll give you an example. You just imagine you want to sit on a chair. Okay? You understand what I meant. So if your orientation should be proper, that means you have to sit in such a way that you should not fall down. Understand what I mean? Suppose if you are keeping your kursi opposite way and you are trying to sit, what will happen?
we will fall.
Yeah, you will fall down. So this is the meaning of orientation. I think it's okay for you, right?
Yes.
Okay, so now condition number 1, it should be properly oriented. Condition number 2, energy of the molecule, they should have some minimum energy. Okay, their energy should be greater than or equal to activation energy. See, look here. Here they are hitting, but there is bond between N and O. Here also bond between N and O. So some amount of energy is needed to break the bond. So these molecules should have some minimum energy. Is it clear for you?
Can you repeat, doctor?
Okay. You know, what's the Arabic word for energy? You know the meaning of energy, right?
Yes.
Okay, so they are hitting each other. See, these two reactant molecules hit each other. So during this process, we have to break the bond, right? This bond between N and O, you will break.
Yes.
See, NO2 means N is just a minute. Here, no, this side. Okay, wait. Here we have NO2 and saying okay, O is there. And CO is coming here, C double bond O, C triple bond O is coming here. So now we will get C double bond O plus something else you will get. So now we need to, so this should hit each other. So we have to break this bond. So to break this bond, we have to give energy, right?
Yes. Okay.
So yes, so the energy of the molecule should be, it should have some minimum energy. Suppose energy needed is 50. The molecule is having energy 60. Reaction will occur or not?
It will.
It will occur because energy needed is 50. It needs it has 60. Suppose if the energy needed is 50 and it has energy 49, will the reaction occur?
No, it won't.
No. Now you understood the meaning?
Yes.
Okay,
Thank you, doctor.
so
Doctor.
yes, dear Sayed. Yes, my dear.
Does the electronegativity do something here?
No, dear. It depends on the bond. During a chemical reaction, new bonds are formed, some new bonds are, old bonds are broken. Okay. Now, strength of the bond has some relationship with the electronegativity and size and all that. But then for the energy as a whole, we can't tell, it's just depending only on electronegativity. Okay, it will have a little role, small role, that's it. Okay, yeah, is it okay?
Yes.
So now tell me, what are the points now? So the two conditions should be satisfied. Okay, suppose if it is properly placed, no energy, reaction will not occur. Suppose it has too much energy and not properly oriented, will you get the product?
No.
No. Okay, so both the conditions should be satisfied. My dear girls, are you here?
Yes.
Yes, no response. Okay, now we will go for a term, activation energy. Did you see activation energy, EA? Is the minimum energy, okay, the molecule should possess for the collision to be effective. So how minimum amount of energy to be supplied, okay? Okay, so how much amount of energy, you understand? How much amount of energy to be supplied is called minimum energy. Okay, now it is always a positive quantity. Activation energy is always positive, it's not negative, it is not zero. Now according to this theory, you don't have to memorize it, it's okay. This is just for explanation sake. Okay, according to this collision theory, rate constant K is given by P Z exponential minus EA over RT. P is the orientation factor. I told you it should be properly oriented. Z is the Carmel number of collisions, that is collision frequency, number of collisions per second. How many collisions are there? Total collision. This is total number of collisions per second. And this is the orientation factor, and this is the energy of factor. This part, see, look here, P orientation factor, it's otherwise called steric factor. Z is the collision frequency or number of collisions per second. This is the fraction of molecules whose energy greater than or equal to activation energy. So if 50 is the energy needed, if it has 50, it will occur. If it is more than that, also it will occur. So that is the meaning. Okay, guys? Okay, understood? Hello? Understood?
Yes.
Yes.
Okay. Now look over here. I have a simple question. This is the relationship. If activation energy is high, rate of the reaction, will it be high or low?
Low.
Low. All of you agree with Sayed?
Yes, doctor.
Yes. Yes.
Why so? Why it is low?
Can I change my answer?
Okay, you change your answer.
I think that it will not affect so much because the exponential does not change much.
Oh, okay.
Can you repeat the question?
Without
No, isn't it directly proportional to the value of K? The rate.
So what is this? You are keep on changing your answers. Okay, let's see. Exponential thing will change, my dear Sayed. Okay, because of that, the thing will change. Look here, dears. You have a negative sign here. Can you see the negative sign?
Yes.
Okay. So because of the negative sign, if EA is high, K will be low. And you know, rate of the reaction is K times concentration of A to the power M. So if K is less, rate also is less. So in short, if activation energy is high, rate of the reaction is less. Did you understand?
Yes, doctor.
Yes.
Anybody has question? Anybody has question, dears?
It's clear, doctor.
If E is high, K is low. So rate is low. Right? Okay. So okay, you understand? So that means that is if activation energy is high, rate of the reaction is less. Why? Because of the negative sign. Okay. It's okay.
What is RT?
R is the constant, no? T is temperature. This is at a particular temperature, my dear.
Yeah.
Okay. Yeah. But actually, activation energy. Okay, we will do the effect of temperature on rate constant. It's there in the portion. We will do it tomorrow, next class. Oh, but you have lab tomorrow, right? Monday. But then lab, this part is there, not this one. Now another part is there, but I didn't reach there. Okay, maybe they will explain it. Now look here, another diagram is this one. Another one is transition state model. The first one was which model? What was the first model? Collision theory, and now this is activation. This is easier than the other one. No, I don't have to explain too much. You will understand. Look here, dears. I don't know if you, okay, so look here, listen. If your question you ask, here you have reactants. Reactants. Did you see? Reactant. This is product, correct?
Yes.
Product. Okay. So now here energy of the product is high, energy of the reactant is less. So this is exothermic. Okay, that I will come back to that. Look. Now reactants should be converted to products. Okay. Yeah.
Yes.
Okay. So in this, I will come back to this slide. I will use another slide. Okay. Okay. This is a big diagram. That's why. Suppose this value is 0. With a value, I'll explain. This value is 0. This value is 20. This value is 35. Okay. Look here, my dear students. Now here, what did I tell this value? 10, right? Okay. Listen. This is the reactant, glucose. These are the products. What's the energy of the product? I'll just write everywhere. Okay. Just a minute.
It's 10, right?
Sorry? Sorry?
It is at the same line we defined as 10.
Okay. See. Look here, dears. What's the energy of the reactant?
20.
20. What's the energy of the product?
8.
8. So it's that means if it loses 12, it will become the product, right?
Yes.
Yeah.
Okay. But actually it will not occur like this. First, it has to go to an activated complex. Reactant molecules should collide and it forms an intermediate. The name of that intermediate is called activated complex. The energy of this activated complex is, how much is the energy of the activated complex? Here it is 35. So initially you have to give this much amount of energy. You have to give this much amount of energy to form the activated complex. So this much is 20. First it has to increase to 35. Then it will lose heat, lose energy. Did you understand?
Yes.
Okay. Anyone has any question you want me to explain again?
So doctor,
Yes, dear, tell
to
me.
form the product, it need 15 plus 12 kilojoule.
No, dear, it's not like that. Just a minute. Just something is. Can I? Where is it? Which is the diagram? This is the diagram. Okay. Okay. Yes, dear. No, it is not like that, Sayed. Okay. Oh, again it went back. Okay. See, actually, do you know the sport event high jump? High jump. Do you know high jump? This is a sports event. High jump. Do you know that? You know that they keep a pole here. Keep a pole here. One person is standing here. He has to jump over this pole, right?
Yes, doctor.
Understood. They keep a pole here. What is the Arabic word for this high jump event?
Yeah.
Okay, no, anyway, that's it. So this person is standing here. This much, too much height is there. He has to jump through this one and go to the other side. So he will be the winner. So, but he cannot go under the thing. You understand? No, he cannot go this way.
Yeah.
He has to jump. Then only he will be the winner. Is it okay?
Yes, doctor.
Okay. So similarly, reactants are not getting directly converted to product. No. From reactants, you will not get the products straight away. Understood that?
Yes.
Okay. First, reactant must form something. That is called activated complex. From the activated complex, they will give the product. Did you understand now?
Yes, so the reactants will lose 27 to form the products, right?
Again, it's going back. Yes, what did you tell, my dear? Reactants?
Reactants will need 27 kilojoule to form the products.
Can you tell me why?
Because they treat the activated complex with
Can
35.
you explain it? Oh, and no, dear. Listen. Reactant molecules are 20 kilojoule, right?
Yes.
We need to give all for the reaction to occur. This much amount of energy we must give. This much amount of energy we have to give. How much?
15.
15. So this energy is called activation energy. Okay. Once it forms this one, then it will lose energy and it will become 8. First, we have to give this much heat. Understand?
Yes.
Okay.
Got it.
First, we have to give this much heat. It will form this complex and then it is converted to the products. Okay. Understand? So the net effect is it has 20 kilojoule. Now it has 8. So that means basically it is losing 12. The net reaction. Why? Because first we give this much and then it's losing this much. Understood?
Yes, doctor.
Okay. Okay. Is it clear for you? So this much amount of this is energy. This much energy is called activation energy for the forward reaction. Suppose if the reaction goes in the backward direction, suppose if it is coming backward, what will happen? Again, the product should form this activated complex. What's the energy of the activated complex?
35.
35. So how much is the energy of activation for the backward reaction? This much is the energy of activation. That is 35 minus 8 is the activation energy for the backward reaction. Is it clear for you? Okay, maybe I think you have some confusion. I will remove this diagram first of all. So it's a mess. Okay, then I will explain. Yes, okay. Look, dears, okay. I know you have confusion. Here, what was the number I gave you? Here, what's the number? 8. What's the number here I gave? 20. What was the number for this one? I gave 35. So, we start with the reactant. Reactant has 20. So, first reactant will form an activated complex. What is the energy of the activated complex? What is the energy of 35? So we have to give this much amount of energy. So what is that? That is called activation energy for the forward reaction. What is the activation energy for the forward reaction? 35 minus 20 is equal to how much? 15 kilojoules. So first we have to give 15 kilojoules for the reaction to occur. Now, in case if it goes in the backward direction, in case, what is the activation energy for the backward direction? Activation energy for the backward reaction.
35.
minus
Yes,
8.
it is. Can you see this one? This one. This is for E. Okay. So EAB will be equal to how much? 35 minus 8 is equal to how much? 27 kilojoule. Now it's okay. Now next is enthalpy change for the reaction delta H. So how do you usually enthalpy change means energy of the products minus energy of the reactants, correct? What is the energy of the product? Tell me the energy of the product.
8 kilojoule.
Product is 8 kilojoule, yes. 8 minus reactant, what's the energy? 20. So what is it? 12 kilojoule. So delta H is negative. This is endothermic or exothermic?
Exothermic.
Yes, it's exothermic process because delta H is negative. Now this delta H you can get in a different way. Look here, EAF. See, if you subtract this one from the blue one, EAF minus EAB. What is EAF? Tell me, what's the value of EAF? This much. What is EAF?
15.
How much? 15. What is EAB?
27.
So what is the answer? Minus 12. See? You have another formula for finding delta H. And the energy of activation of forward minus energy of activation of backward. Now, for exothermic reactions, energy of activation of, which one is greater? Energy of activation for forward or backward?
Backward.
Energy of activation of backward is greater than energy of activation of forward. Now it's clear for you? Is it okay?
Yes,
Yes.
sir.
Understand? Okay, so now there's a question for you to do. Okay? Yeah? Okay, tell me, energy of activation for forward reaction, what's the value?
50 minus 10.
Yes, 50 minus 10 is equal to how much? I will use a different color. Yeah, 50 minus 10 is equal to 40 kilojoule. Backward reaction.
50 minus 20.
This one is not, I didn't mark it properly. It's coming somewhere here, right? So maybe it will come around 25, right?
Yeah.
Correct? Okay, so it will be, tell,
50 minus 25.
is equal to 25 kilojoule. Now, enthalpy change, product minus reactant. Product,
25.
reactant,
And
reactant, 10.
10.
So it's 15 kilojoule. This you can get from this diagram. I mean, this formula. Forward, how much? Forward, how much?
40.
40. Backward, how much?
24.
So the answer is same. So this is endothermic or exothermic process?
Endothermic.
Yes, so that means for endothermic process, tell me, complete a sentence.
EA forward is higher than EA backward.
Yes, yeah, backward. I hope now it's perfect for you, right? Okay. See, I'll give you some questions. See, can you see? You tell me, first one endothermic or exothermic?
First one is
This is reactant.
Exo.
This is product. Here it's reactant, product. Yes, the first one.
Exothermic.
Exothermic.
So this is number 1. This is number 2. So this one is exothermic. Now, what is EAF? Oh, What is EAF according to this one? Hmm. Come on. EAF, what is EAF here? It's marked, no? What is EAF here?
1,
Is the
doctor.
3.
EA is what number?
3.
3, yes. Oh, when I breathe, it's moving. Yes, EAF is 3. EAB?
Plus 3.
Is 2.
EAB is what?
4
2.
plus 3.
What? Product to the other one. So it will be? Yeah, tell. EAB. How much is EAB here? Till here, no? This much is
3
EAB.
plus 4. 3 plus 4.
Yes, it's 3 plus 4. And what's the energy of the delta H? What is delta H? Delta H.
EAF minus E.
Not yet. Delta H from the number, from the figure,
For doctor.
3
What?
minus 7, doctor.
There is a direct one, no? There is direct number. Yes, dear?
Number 4.
Yes, it's number 4. Oh my God, I don't know what's going on here. Number 4. This is a product, this is a reactant. This one is delta H. Okay? Now.
But doctor, since it is an exothermic, it should be in minus, right?
Yeah, delta H will be minus. It's here we are just taking the magnitude, no dear. This is just the numbers.
Okay, doctor.
It gives, of course, it's negative. Okay. Now here, tell me the process is, of course, you endothermic. Then
It's exothermic, doctor.
Exothermic, doctor.
which one?
It is exothermic.
Both of them are the same. I am supposed to do something opposite. Okay. Anyway, it's okay. Leave it. So you understood the meaning, right?
Yes.
I wrote the wrong diagram, my dear. I brought the wrong diagram. It's okay. So now we will go back. Okay, see, look over here. Did you see? First
Yes.
one is which one? First one is what type of reaction?
Exothermic.
Yes. Second one is endothermic. So exothermic reaction product is having lower energy and reactants having higher energy. Here it is in the opposite way. So I hope you understood the energy really. Yeah, here look, in the, since it is exothermic, in this case energy is, this is delta H, energy is released. Here energy is absorbed. So delta, here it is positive, the other one is negative. It's okay for you or not?
Okay.
Everyone understood? Or do you have some confusion? If anyone has any question, I can explain it again, don't worry. Any confusion? No confusion, right? No one is telling anything, okay. Okay, yes. Now, there's a question. Can you see?
Yes, doctor.
Yes.
Yes.
Doctor.
Yes, tell me the answer. Delta H is what's the formula? Delta H is equal to, tell me, EAF minus EAB. So delta H is 20 is equal to, forward is 25 minus EAB. So EAB is equal to how much?
25 minus 20.
Yes, 25 minus 20 is equal to 5 kilojoule. Okay, yeah.
Okay.
Now, What is this? Catalyst. I think Musaf is something like that. Musaf is correct. Catalyst.
I don't know, doctor.
Okay. Okay. I don't know. I didn't. Catalyst is a substance which increases the rate of the reaction without being consumed. Did you understand the meaning of the sentence, or you want me to explain?
Doctor.
Understood?
Yes.
Okay, so that means we have A plus B giving C plus D. This is the reactant. These are the products. Suppose to make the reaction fast, you are adding a catalyst. Say we add catalyst E, and along with the product you get the catalyst back. Understand now?
Yes.
Okay, so you are adding the catalyst. So, and you are getting it back. So usually when we write in a different way. A plus B giving C plus D. On the arrow we write catalyst. Okay?
Okay. Okay, doctor.
E the catalyst. I hope you understood now. Now, what is this catalyst doing? Look, I told you about the high jump. Do you remember that high jump? I told you high jump.
Yes.
Yes, so the pole, the height of the pole is one boy is standing here. So he wants to jump. Okay. Suppose if the height of the pole is too much, he cannot jump, right?
Yes.
No, suppose so many participants are there, so many students are there for this competition. Now, no one can jump. So what the people will do?
They will bring the bar down.
Yes, that's it. So what do? They bring it down. So before it was here, now they bring it down. So what will happen? The people can jump over. Understand? Easy. So this is what catalyst is doing. Look here. Can you see this blue line on the diagram? Blue line.
Yes.
So this is in the absence of catalyst. Blue one, this one, in the absence of catalyst. Okay. Now, in the absence of catalyst, what is the activation energy needed for the reaction? Tell me. In the absence of catalyst.
30.
Yes, okay. Energy of activation in the absence of catalyst. How much? 50 minus how much? 20, right? How much? 30 kilojoule. Now, energy of activation in the presence of catalyst.
5 minus 20.
So what is the value? What is the value?
35 minus 20.
35 minus 20 is 15. So what is catalyst doing?
Is making the process faster.
Yes, it will make it faster. See, I will give you an example, okay? From your home to UOB, just imagine all the problems are over. You are next semester, you are going back to UOB. So your house is in Muharrak. Okay, you want to go to UOB, okay? So you can go by walking. You can go by car, right? You can go by walking. But in morning, if you start, maybe evening you will reach there, right? Correct?
Yes.
Yes. By car you can reach, I don't know how many kilometers per speed you drive. How many minutes you need to reach UOB?
I don't know, doctor.
Oh, you haven't gone. Oh my God. Okay. Suppose you take 40 minutes. Just imagine 40 minutes. Okay. But in both cases, the distance is same, right? Muharrak to UOB, distance is same. There is no change. But by car, what is happening?
We are moving faster.
Yeah, you reach fast. That is the only thing Catalyst is doing. Catalyst will not give you more products. Catalyst will not give less product. Okay, Catalyst will not change enthalpy. What is Catalyst doing? Catalyst will make it very fast. Now understood? So imagine you are coming by car. So the car is a catalyst. Is it clear for you?
Yes, Doctor.
Yes.
So what is catalyst doing? Catalyst increases the rate of the reaction by
Decreasing the energy
decreasing
activation.
the energy of activation. Catalyst will not increase the amount of the product. It will not decrease the amount of the product. Delta H value remains the, see, look at the thing. Delta H remains
The same.
same. In the absence or presence, delta H remains same. It is only changing that activation energy, and so that rate of the reaction will increase. It does not give more products. It doesn't give less products. Then the amount of the product remains the same. Delta H remains the same. Only thing is, it will be, reaction will be faster as activation energy is lower. Okay, is it okay? It's okay, no? Understood? Okay. Okay, so then bye-bye. Let me don't go. I want to take the attendance, please. Don't go. Let me download the attendance, please. Just a minute. Okay. Okay, now you can leave.